Good day, Doctor. We are Group 13 from Section 41. We are given 200 sample observations of pills with different relative density and tensile strength produced by workers of 3 different shifts. In this report, we will be describing the summarized data in numbers, graphs, and tables, as well as verify if the tablets are normally distributed and meet the requirements set. We will also discuss about the difference in weight of tablets produced in different shifts and predict tensile strength of tablet using the data we have.
Straight to the point and going back to the basic chapter for this whole project data, we should already know that the whole project data given like this one is actually a descriptive statistic type of data as we are wanted and already could treat the data given. But to analyze and summarize this data, what actually the things that we need to know? Because just look at this data where it is not even arranged properly and it is hard for us to read. Therefore, firstly we need to do is we need to make a new data or new table by doing tabular method, where from these things we can actually kind of sort the data if necessary through anything that we wanted, either maybe from their value or from the shift, just like in this case. Right. For these things, as I said just now, for this table analysis, since there's no specifications on what we are finding, so just extract anything that we could. For the tabular analysis, can see here that since there's no specifications made, so we just extract anything that we could. And for the weight, we have made the intervals of 10 from 305 to 315 milligram for each intervals. And we could see here the frequency is starting from 2, 12, 17, and going through to the total of 200. And same cases for the relative density and also for the tensile strength. And then from the previous tables, we can make a numerical analysis where we could find the samples average or mean or the X bar, as well as the standard deviations and also the variance, where all of this actually can be calculated manually by handwritten or calculator, or in this case by using the Excel, of course. And then where we can see here, we made both of the overall and then by the shifts data for the numericals analysis. Then lastly, we can make graphical analysis by doing some representations of the data into a picture of graph, either from the chart or maybe line graph and so on, based on the specifications or things that we are looking for. And since this is a qualitative thing, and since this is a quantitative data, and since this is a quantitative data that we can calculate it, then we have chosen histogram charts to represent the data. And with all of these three basic summarizations from the data analysis, we could finally continue with other statistical analysis.
Okay, next question is question B, where we are asked to give the comment from the manufacturer's claim that the FDA authority has required the manufacturers to make sure the weights of each tablet has a standard deviation of 14 milligram and also mean of 350 milligram and follow the normal distributed. So for this question, we have made the chi-square test, and that's what you guys can see. The chi-square test gives the answer of 16.86306. Okay, next. So we have assumed a significance level at 5%, and we have done the hypothesis test. For H0, we have put the data is follow the normal distribution, and for H1, the data is not follow the normal distribution. And from this hypothesis test, we have come out with a decision which the chi-square test is exceed the hypothesis test. That means the conclusion that we can make here at 5% level of significance, there is sufficient evidence from the data to reject the manufacturer's claim that the weights distributed from the manufacturers is not follow the normal distribution.
So for question C, we need to find out whether there is a significant difference between the weight of the tablet from different working shift. So in this case, we have three population need to be tested, which is the working hour. We got the morning shift, evening shift, and night shift. And because of that, we need to do the one-way ANOVA analysis. For the hypothesis test under H0, the mu1 and mu2 and also mu3 is equal. Under the H1, the mu I is not equals to mu j for at least one ij. And we reject H0 if the F calculated value greater than the F critical value. By using the data analysis toolpath under the ANOVA single factor, this is the output generated. We got the summary table, and inside this summary table, it contains the sample size, the summation value, the average value, and the variance value for different working shift. And this value will be used to construct the ANOVA table. For the ANOVA table, it is similar to the manual ANOVA table we did, but the F critical, instead of using the statistical table, the value also generated for Excel, which is equals to 3.041753. From the ANOVA table, the SSTRT, the SSE, and also the SST value also calculated. And by using the SSTRT and the SSE value, we can calculate the F value, which is equals to 1.052475. By comparing the F and the F critical value, we can clearly see that the F is less than the F critical, and because of that, we do not reject H0. For the conclusion, we can conclude that alpha equals to 0.05 level of significance. There is no significant difference in the output of tablet weight due to different working shifts.
For this part, I will explain about how to predict the tensile strength based on the relative density. With tensile strength is the dependent variable and the relative density is the independent variable. This output is collected from the Excel. As we can see, the R value is close to +1, which indicates it is less scattered and have a strong positive linear relationship between the relative density and the tensile strength, while the R square indicates that around 70.59% of the data fits the regression model, which can explain the value of the tensile strengths and show that the simple linear regression model is adequate to explain it. Next, the Anova table, where a linearity test can be conducted using the F-test. With the null hypothesis, which is H0, beta is equal to 0 and H1 is beta not equal to 0. With the decision rule of rejecting H0 if F-test is larger than 3.8889, and from the table, we can see that the F-test is much more larger than the F-critical. Hence, we can reject H0 and conclude that the linearity exists between the tensile strength and relative density at 0.05 level of significance. For this table, the t-test for beta can be used to conduct a positive linearity test, which H0 where the beta is equal to 0 and H1 is beta is larger than 0. With the decision of rejecting H0 if F-t-test is much more larger than negative 1.6526, from the table we can see that the t-test is much more larger than the t-critical, hence we can reject H0 and conclude that at 0.05 level of significance, there is a positive linearity exists between the tensile strength and relative density. And from the coefficient, which is here, the intercept is alpha and the relative density is known as beta. We can get a fitted line regression equation, which is this, where we can use it to predict the tensile strength based on the relative density. But because of the relative density of the data in December 2020 range from 80 1.8 to 93.9, the prediction of the tensile strength list here is invalid due to the reason it predicts beyond the range of the data obtained and relies on the untestable assumption of the data. The normal probability plot shows that the point scattered close to the straight line, where we can assume that the normality of the tensile strength is satisfied, while the relative density shows a randomly scattered pattern around the zero axis, indicating a good fit for a linear model. That's all from us. I hope that our information about the tablet are clearly presented.
That's all from our group. Thank you.